Hi class, how are you today? That's a greeting. See, by me saying, Hi class, how are you today? That's how I'm greeting you. The learning target for today is to explain, identify the types of, and create a random sample. For the scale, you're a 3 if you can explain, identify the types of, and create a random sample. You're a 2 if you can do 2 of these things. You're a 1 if you can do 1 of these things, and you're a 0 if you can do none of these. Let's get started. Section 1.2, Random Samples. The focus points of this lesson are to explain the importance of random samples, construct a simple random sample using random numbers, simulate a random process, and describe stratified sampling, cluster sampling, systematic sampling, multi-stage sampling, and convenience sampling. These are different kinds of random sampling techniques. Simple random samples. In this section, we will examine several widely used sampling techniques. One of the most important sampling techniques is a simple random sample. A simple random sample of n measurements from a population is a subset of the population selected in a manner that every sample of size n from the population has an equal chance of being selected. So pretty much what it is you just have a group and you randomly choose some number from that group. So if you have 10 people in your group and you randomly select 3 of them. In a simple random sample, not only does every sample of specified size have to be an equal chance of being selected, but every individual of the population also has an equal chance of being selected. However, the fact that each individual has an equal chance of being selected does not necessarily imply a simple random sample. Remember, a simple random sample, every sample of the given size must also have an equal chance of being selected. So what that means is there are many different ways to choose a random sample, but for a simple random sample, you've just got one group and you randomly choose a certain number from that group. However, there are other ways of sampling, such as splitting that group into smaller groups and then choosing. An example could be if you have a group of 100 and you split it up into groups of 10, and then you want to select one person from each of those groups, what you have there, each person has an equal chance of being selected. However, you can't have a group, your group that you select cannot be, you can't have 2 people from the same original group because you've only chosen one from each. So your sample that you're getting, in that case, not all of them have the same chance of happening. And in this case, actually they have no chance, some of them have no chance of happening. All right, here's an example. Using a random number table. You have random number tables in the appendix of your book that you'll be using. So in this example, use a random number table to pick a random sample of 30 cars from a population of 500 cars. So to do this, first we assign each car a different number between 1 and 500, including 1 and 500. Then we use a random number table to choose the sample. In the table 1 in the appendix, as I just mentioned, there are 50 rows and 10 blocks of 5 digits each. It can be thought of as a solid mass of digits that has been broken up into rows and blocks for user convenience. You read the digits by beginning anywhere in the table. We dropped a pin on the table, and the head of the pin landed in row 15, block 5. We'll begin there and list all the digits in that row. If we need more digits, we'll move on to row 16 and so on. The digits we begin with are, and here are the digits. So they dropped a pin on the table and it landed on row 15, block 5. So we start off with these digits. And we're going to use these digits to randomly choose our group. Since the highest number assigned to a car is 500, and this number has 3 digits, we regroup our digits into blocks of 3. So instead of having 5 digits each, they have 3. Then, to construct our random number sample, we use the first 30 car numbers we encounter in the random number table when we start at row 15, block 5. We skip the first 3 groups because these numbers are too large. If you are trying to do this and you get a number that's larger than 500, you can't use it, so you skip to the next one. So that means the next group of the 3 digits is 0, 1, 5, or 15, which corresponds to 15. Car number 15 is the first car included in our sample, and the next car is number 221. We skip the next 3 groups and then include card numbers 105 and 371. To get the rest of the cars in the sample, we continue to the next line and use the random number table in the same fashion. If we encounter a number we've used before, we skip it as well. So, quick review of the procedure and how to draw a random number sample. Number all the members of the population sequentially. Use a table, calculator, or computer to select random numbers from the numbers assigned to the population members. So we're going to learn how to use a table as we just did, but also there are other ways such as using a calculator. I'll be showing you how to use that. And you can also use a computer to do it as well. And number 3, create the sample by using population members with numbers corresponding to those randomly selected. So you take your people and you actually give them numbers. That way you can order them with numbers. Another important use of random number tables is in simulation. We use the word simulation to refer to the process of providing numerical imitations of real phenomena. Simulation methods have been productive in studying a diverse array of subjects, such as this list. A complete list, though, would probably include something from every aspect of modern life. A simulation is a numerical facsimile or representation of a real world phenomenon. So, essentially what that is using random number tables or calculator, computer, or whatever it may be to simulate, to use a real life thing happening, and we're going to simulate it. We're going to use the computer to show what would happen in a certain case. Because a lot of times you can't actually sample things because, say, they're a phenomenon that don't happen very often, or possibly unethical things that you would never actually study. So instead you use a simulation to simulate what would happen. Other sampling techniques. Although we will assume throughout this test that random samples, simple random samples, are used, other methods of sampling are also widely used. Appropriate statistical techniques exist for these sampling methods, but are beyond the scope of this test. One of these sampling methods is called stratified sampling. So, always assume that it's going to be a simple random sample unless they tell you otherwise, but in an intro to statistics class, the stuff we're mostly going to see are simple random samples. One of these sampling methods is called stratified sampling. Groups or classes inside a population that share a common characteristic are called strata. For example, in the population of all undergraduate college students, some strata might be freshmen, sophomores, juniors, or seniors. So we're taking a population, undergrad college students, and we're splitting them up into groups. Other strata could be men or women, in-state students or out-of-state students, and so on. In the method of stratified sampling, the population is divided into at least two distinct strata. Then, a simple random sample of a certain size is drawn from each stratum, and the information obtained is carefully adjusted and weighted in all resulting calculations. So in this way, you're splitting them up into groups that make sense, and then you're doing a simple random sample inside each group. So you're taking a simple random sample of a simple random sample of the freshmen, a simple random sample of the sophomores, of the juniors, of the seniors, and then doing that. Another popular method of sampling is called systematic sampling. In this method, it is assumed that the elements of the population are arranged in some natural sequential order. Then we select a random starting point and select every kth element for our sample. For example, people lining up to buy rock concert tickets are in order. To generate a systematic sample of these people and ask questions regarding topics such as age, smoking habits, income level, etc., we would include every fifth person in line. The starting person is selected at random from the first 5. The advantage of a systematic sample is that it is easy to get, however, there are dangers in using systematic sampling. So you randomly say you want to start with the third person, and then you talk to the 8th person, and then you talk to the 13th person, and then the 18th person, and the 23rd person, and so on until you get to the end of the line. So you're not asking every single person in line, you're just asking a set number of them, specifically every 5th person. So it's not a random sample because you are always skipping 4 people. 4 specific people will always not be seen between those. When the population is repetitive or cyclic in nature, systematic sampling should not be used. For example, consider a fabric mill that produces dress material. Suppose the loom that produces the material makes a mistake every 17th yard, but we only check every 16th yard with an automated electric scanner. In this case, a random starting point may or may not result in detection of fabric flaws before a large amount of fabric is produced. So in this case, if we went to every 16th, but it actually made the mistake every 17th, what we would see would be that it never made a mistake. However, it actually did make a mistake 1 out of 17 times. So that's why in this case, a simple random sample would be much better. Another sampling technique is cluster sampling. It's a method used extensively by government agencies and certain private research organizations. In cluster sampling, we begin by dividing the demographic area into sections. Then we randomly select sections or clusters. Every member of the cluster is included in the sample. For example, in conducting a survey of school children in a large city, we could randomly select 5 schools and then include all the children selected from the school. Often a population is very large or geographically spread out. In such cases, samples are constructed through another type of sampling technique called multi-stage sample design. It's several stages with the final stage consisting of clusters. So in this, we use many different techniques, but different stages of them. So in one stage we use one technique, and another stage we use another technique, ending in the cluster technique. For instance, the government's current population survey interviews about 60,000 households across the United States each month by means of a multi-stage sample design. For the survey, the first stage consists of selecting samples of large geographic areas that do not cross state lines. These areas are further broken down into smaller blocks, which are stratified according to ethnic and other factors. Stratified samples of the blocks are then taken. Finally, housing units in each chosen block are broken into clusters of nearby housing units. A random sample of these clusters of housing units is selected, and each household in the final cluster is interviewed. So many different stages there, using different techniques, getting down to what they want. Another technique is convenience sampling. It uses results or data that are conveniently and readily obtained. In some cases, this may be all that's available, and in many cases, it's better than no information at all. However, convenience sampling does run the risk of being severely biased. For instance, consider a news person who wishes to get the opinions of the people about a proposed seat tax to be imposed on tickets to all sporting events. The revenues from the seat tax will then be used to support a local symphony. So you're taxing people at sporting events in order to support a local symphony. So the news person stands in front of a concert hall and surveys the first 5 people exiting after a symphony performance who will cooperate. So, as you see there, what happens is the tax will benefit a symphony, and he asks people who just came from a symphony. So those are probably going to be pretty biased. This method of choosing a sample will produce some opinions and perhaps some human interest stories, but it certainly has a bias. It is hoped that the City Council will not use these opinions, because they're extremely biased, as the sole basis for a decision about the proposed tax. It is good advice to be very cautious indeed when the data comes from the method of convenience sampling. So just a quick review of sampling techniques. We call the list of individuals from which a sample is actually selected the sampling frame. Ideally, the sampling frame is the entire population. However, from a practical perspective, not all members of a population may be accessible. For instance, using the telephone directory as the sample frame for residential telephone contacts would not include unlisted numbers. So if you're just taking from a phone book, not every person would be there because they may not have their number listed or they may not have a phone, but that may be the only way you have of randomly selecting people. So the sampling frame would be everyone in the telephone book, while the population is everybody. When the sample frame does not match the population, we have what is called undercoverage. In demographic studies, undercoverage could result if the homeless, fugitives from the law, and so forth are not included in the study. In general, even when the sampling frame and the population match, a sample is not a perfect representation of a population. Therefore, information drawn from a sample may not exactly match the corresponding information from the population. So that's what we were talking about last class that Tyler brought up. So in that case, what happened was, if you've got polling, they're just taking a sample of people who have voted, or samples of people who are planning to vote. However, it's not a representation of everyone who's going to vote. So that's why they often have a margin of error, because there is error. To the extent that the sample information does not match the corresponding population information, we have an error called sampling error. And we'll find out much later in class how to calculate that sampling error. What is the margin of error? So a sampling error is the difference between measurements from a sample and a corresponding measurements from the respective population. It is caused by the fact that the sample does not perfectly represent the population. A non-sampling error is the result of poor sample design, sloppy data collection, faulty measuring instruments, bias in questionnaires, and so on. So if you have a good sample, you still have an error because of the fact that it's a sample. But a non-sampling error would be something based on what you did to collect the sample, an error you made in collecting the sample. Now time for the sponge activity. We have a few questions here, and I want you to answer them to the best of your ability. Number 1, a random sample of parents who attended a high school football game were asked if ticket prices to high school games should be increased to better high school sports. I want you to describe the sample frame, and then why might this not be the best way to gain information about increasing ticket prices. Number 2, in a random sample of 15 cereal boxes taken from the shelves of a grocery store, all of them had a height of 12 inches. Can we conclude that all the cereal boxes in the store were 12 inches tall? Explain. And number 3, in a high school, 10 students from each grade were randomly selected to be on a committee. Part A, does each student have an equal chance of being selected? Explain. And part B, which of the sampling techniques was used? And explain. Anywhere it says explain, I want more than just the answer, or I won't take it. A lot of statistics is not necessarily whether you know whether it's this or this, it's explaining, it's knowing why something is. So a lot of questions now will be explain this, more than just is it this or this. Alright, that's it for the lesson. Once again, please take notes in the entire lesson. Attempt the sponge, submit it all to eBackpack. Google Classroom. I use Google Classroom now, just to make sure you knew that. Google Classroom. And have a good night.